Hello everyone. Myself Kumar Gaurav. I am from CSE department, second year, and I am here to explain about dynamic programming. So, let's begin. So, the objective of today's presentation is we will be taking a brief introduction of dynamic programming. Then we will shift our focus to one of its most famous problem, the traveling salesman problem, which have tons of application in real life. So, let's begin. Introduction. What is dynamic programming? It is a problem solving technique among the many which we study. It works on the principle of divide or conquer or principle of optimality. So, in simpler words, the concept behind dynamic programming is that we break the problem into sub problem so we can use that for future use, so we don't have to so we don't have to compute the same problem again and again. In this, we break the problem into sub problem. So, what are optimal problems? If a problem has only one correct solution, then it is not optimized. For example, arranging a set of number in defined sequence. Optimization problem may vary according to situation. For example, calculating minimum cost in buying a product, maximum gain in a transaction, minimum fare for a travel. Why dynamic programming? These all depends upon various situations. Their answer can vary according to situation. Dynamic programming is a very tool that comes into play. It works by dividing the major problem into smaller chunks, partition of problems into independent subproblem, solving the subproblem recursively, combine their solution to solve the original problem. We can use dynamic programming only when the problem which we are solving share the same sub problem with uh, we can only use dynamic programming when we are using the when sorry I will repeat again. So dynamic programming is used when the sub problems are not independent, that is when they share the same sub problem with each other. So now we are going to discuss its most famous application. It's one of its most famous application of dynamic programming, which is the traveling salesman problem. So here given, so I'm gonna read the problem statement. So given a list of cities and the distance between each pair of cities, what is the shortest possible route that visits each city and returns to the origin city? So this is the problem statement. Now I'm gonna explain. So here we can see a undirected graph, which is referring to the which is referring in this undirected graph. A is the starting vertex. See, I have written A is the starting vertex, and we have to calculate the shortest path in traveling from A to all the possible vertex, and then we have to reach back to A. So, so for solving this type of problem, first of all, we have to write the cost matrix. So we will write the cost matrix like this. For A, it's 0 because it is on the same position. For AB, it is 2. See, the salesman is in position A. So he is moving from A to B. So we have to write the value for AB is 2. For A to C, 2. C. For A to C, it's 2. For A to D, it's 1. C. For A to D, it's 1. For A to E, it's 4. C. For A to E, it's 4. So we will write the values I discussed for A. So we will do apply the same logic for B also. BA, it's 2. See, BA, it's also 2. For BB, it's 0 because it's on the same position. For the BC, we have to write 3 because B to C is 3. And for BD, we have to write 2. And for BE, we have to write 3. So for CA, we have to write 2 because C to A is 2. For CB, we have to write 3. For CC, we have to write 0. And for CD, we have to write 2. And for CE, we have to write 2. See, CE is also 2. So we will write same for D and E also. Now, as I told earlier that A is the starting vertex. So the formula for calculating the shortest path is like this: G of I comma S equal to J belongs to S, the minimum value of Cij plus G of J comma S minus J, where S is the set, and I will explain the other terms in next page. And our objective is to find G of A comma B C D E, which is the shortest path to travel from A to B and return back to A. So next. So yeah. So here, let G of Is be the length of the path of the starting vertex I, going through all the vertex in set S and terminating at starting vertex A. Me so here we can say that G of Is is the length of path starting from the vertex I. Here vertex I is referring to A, which was here vertex I is referring to the starting vertex A, which I explained earlier. See, this A is the starting vertex I. So and S is the set from S is the set of the path from the salesman will travel. So now now we will be proceeding to our solution for the now we are moving to stage 1. So now we will write like this: G of B comma phi. We will make all the possible combination with phi. So this means that that salesman is traveling from B to phi and it is reaching back to A. We can compare this G of B comma phi to G of I comma S because and you can understand like why I am referring to this. So it means that G of B comma phi is the length of path starting from vertex B, starting through vertex B, going through all the vertex in set phi and terminating at vertex A. So phi means nothing. This is a null set as we all know. So this means B comma A. Now we have to write the value of B comma A. So we can write this value from our cost matrix, or we can write the value from direct from graph. So we can see here the value of B comma A. So we zoom it. The value of B comma A is 2. Okay. So we have written 2 here. Now we will be writing G of C comma phi is also 2. G of D comma phi is 1. G of E comma phi is 4. We are using the same concept as we use in B comma phi, and we have written this values from the cost matrix. So as I explained earlier, in stage 1 we will make all the possible combination with phi. Now moving to stage 2, we will be make the combination with the other elements rather than using phi. Now our first function is G of B comma C. Now I'm gonna explain why I am using G of B comma C, G of B comma D, G of B comma E, and so on. So let me take you back to the graph. So yeah, zoom it. So now I'm gonna explain that why I am using like B of C comma B of C, B of D, because we are saying from how many possible ways from B we can go through A after traveling this distance. So we are seeing that we can also move to A by B to D, then D to A. So we can make one combination as B comma D. Okay, why B comma D? Because G of B comma D means that we are starting from vertex B and moving through that set D, and we are returning back to the initial vertex, that is A. So we can make one possible combination as G of B comma D. Then another one is G of B comma C, because we can from B we can go to C, and directly from C we can go to A. So one possible combination is G of B comma C, and our other combination is G of B comma E, because from B we can go to E, and from E we can go to A. So our one possible combination is G of B comma E. So by using this concept, we can apply the same logic to G of C comma B also. Like for example, C, G of C comma first, our first combination from DC will be G of C comma A, because from C we can directly go to A. So that is G of C comma A. We can move through via VIA through B also, like so we will go first to C to B, then B to A, then C to D, and D to A, then C to E, then E to A. So by this concept, we can make the subsets. So I think you understand how I have used this possible combination like GBC, GBD, GB, GCB, and so on next week. Now I'm going to explain how this value has come. Now I have applied the formula which I have written in the first page. Yeah, now I am using this formula. So as you can see that G of I comma S, like G of B comma C, equal to minimum value of C of B comma C plus G of G of J comma S set, the whole set minus that J. So here we can apply the logic, and we are getting the value of CBC. This value we can get through the cost matrix. Let's see the what is the value of CBC. So for BC, the value is 3, as you can see from the cost matrix. C, B, and C, the value is 3. So yeah, we can get it through the cost matrix, and plus G of C comma 5, where this 5 has come, that like C minus C, this is 5, because G of C comma 5. Why this I have written this C? Because we can directly compare to this to the formula. So 3 plus G C comma 5. So from the cost matrix, I have written the value of CBC. Now I am referring the value of G of C comma 5 from here. C. Here G of C comma 5 is 2. So we can take this value as 2. 3 plus 2, 5. So there is no 2 function, then we can only write 5. So by applying the same logic, we can use this for G of B comma D also, G of B comma E also, G of C comma B also. So we can now say that, yeah, for G of C comma D also, as I explained how we are forming these combinations, so we can apply the same logic and find these results. Now we have to store these results for future use, as I have explained about dynamic programming, what it is. Now we are moving to stage 3. Here we will be putting 2 values rather than 1. So let me recall for the first stage. we are making combination. We are making the combination of vertex with set 5. For the stage 2, we are making combination with only one element, and for stage 3 we are making the combination with two elements. Like for example, we are using g of b comma cd. As I have explained, this you can also understand this. Let me take you back to the graph. Yeah, g of b comma cd. So we can say g of b comma cd. This is cd, and from c to d and d to a. For g of b comma ed also, because from b we can go to e, from e we can go to d, and from d we can go to a. So these are the combination which we are referring here. So now we're back to the stage 3. So yeah, now after putting those formula, we are getting here two functions, like minimum of this function plus comma this function. So the minimum of 6 comma 6 is 6. So now we will be form the other combinations. So now we will take the minimum values from this, minimum value from this, minimum value from this, minimum value from this. Let me explain how. Let me explain how we are comparing these values to the formula, which is, wait a second. Let me explain how we are referring this value to formula to make you clear once more. Okay. So, for example, g of b comma cd, g of b comma cd. So here is the formula. So we can put it here. For example, g of b as I and cd as set s. So here is the formula c of I comma j. So I comma j means wait a second. Wait, yeah. So this BC is I comma J, and J, here and here J comma D. Here I have written D after subtracting the set from after subtracting J from the set, and the set is CD. So CD minus D, because the formula was set minus J. So I am after subtracting CD minus D, I get D. So by this, I have applied the formula to these uh, functions. So I have made the other possible subset for these, and I have written the minimum value for this. Now, yeah, I have made the other possible combinations here. G of t comma bc, G of t comma be, G of t comma ce, G of e comma bc, G of e comma cd, G of P comma D. Okay. So now moving to stage 4. Now here uh, we will be comparing with three elements, three vertices. Like for stage 1, we made the combination with 5. For stage 2, we used only one element, one vertices. Now for stage 3, we used two, and now in stage 4, we are using three as B, C, D, E. Here also we will be using the same logic for making the subset as I have discussed earlier. So now here we will be getting three functions for calculating the minimum value. For example, minimum of C of BC plus G of CDE, comma CBD plus G of DCE plus CBE plus G of ECD. So how will we get this function? Let's see. So here B, C is Ij, and C is J, and DE is the result of this set minus the J. So the set is CDE minus, what is J? C. So when we subtract CDE minus C, we get only DE. So now here, what is J? J is D. So the whole set CDE minus D, we get CE. So I applied the same logic here. So minimum of 3 plus 7, 2 plus 8, 3 plus 5. So minimum of 10 comma 10 comma 8, 8. So I use the same logic for this. G of C comma B D E, G of D comma B C E, G of E comma B C D. So now we move to the stage 5, which is the final stage. Now, this, as I have shown you earlier, our objective was to find G of A, comma B, C, D, E. Now, in this stage, we will be using four vertices with combination with A. So here we will apply this formula, apply the original formula with reference to these values. For example, for example, wait a second. Yeah. So here G of A comma, first we will be using G of A, we will be using like this, but I have solved these things, and after applying the same logic which we have used in the earlier calculations, we get four values. So in these four values, we will be taking the minimum value from this four function. So the minimum value is 10. So 10 is the minimum cost of traveling of salesman. So and the path is from A to B, B to E, E to C, C to D, and D to A. So this ends our calculation from for traveling salesman. Now, the traveling salesman problem has lot of application in our lives. Logistics of delivering goods, drilling holes in circuit boards, genome sequencing, programming space telescope, making travel itineraries, X-ray crystallography. So yeah, some of the real life application. Airlines flight consists of multiple legs. A flight leg is a unit of flight consisting of one takeoff and one landing. They need to allocate crew people to flights such that at the end of their duty, every crew member is back at their home for airport. So these all things are done. Uh, these all things are done by applying the logic of traveling salesman problem, as I have discussed the problem earlier. So another application of a traveling salesman problem. The traveling salesman problem can be applied to find the optimum path to drill multiple holes. Like consider that you have to drill multiple holes in a given street, and the corresponding CNC drilling machine is also identified. Then you just have to make a program guiding the tool from one location to another, which you can find out through the traveling salesman problem. So these were some of the real life application of traveling salesman problem. So conclusion, dynamic programming has become one of the core methods to solve a lot of problems. It is used widely in the economics it is to aerospace engineering. It has a very large applications. So it is also widely used in Google Maps. Lastly, I am very grateful to our respected ma'am for their guidance and support. So thanks a lot.